most definitely worth the trip. I first saw the word in 2010 when my friend Ross sent me a one-word text, Rhizophagy. At first I thought he was calling me a weird name, but I knew the word's Greek roots, rhizo, root, phagy, to eat. So, rhizophagy, root eating. No other information was available back then. I eventually learned that rhizophagy was root cells engulfing microbes and using them for nutrients. I filed it away. Fast forward 10 years. While reading up on endophytic bacteria, those that live inside plants for part of their lives without causing the plant harm, I came across research papers on the subject of rhizophagy by James Francis White, a professor at Rutgers University. His team confirmed and expanded earlier studies conducted by Chanyarat Pongfu Longyin and her associates at the University of Queensland, Australia. These scientists deserve our attention. Nobel Prizes for you all. Endophytic bacteria are found inside every single plant. They usually help the plant by aiding nutrient acquisition, increasing stress tolerances, and controlling pathogens. Yet little is written about endophytic bacteria for the gardening world. What's more, it appears a new plant microbe nutrient cycle is in play. Bacteria move from the soil into young root cells at root tips. As they do, they trigger the plant to produce chemicals that dissolve the bacteria's cell walls. Amazingly, the wall-less bacteria remain viable and actually increase in number as they are circulated around the outer edges of the root cell, and the dissolved components of the bacterial cell walls become plant nutrients. In an attempt to neutralize the wall-removing chemicals, the intracellular bacteria produce nitric oxide. This is converted to nitrates, and these too are absorbed by the plant root cell, more nutrients. And all the while, these bacteria are releasing ethylene into the plant cell, causing the cell to elongate. When enough of these wall-less bacteria accumulate in the root cell, their ethylene causes a root hair to form, and they are ejected from its tip back out into soil. The formerly endophytic bacteria, now living in soil, rebuild their walls, fatten up, and repeat the cycle. Breaking news. Wait, what? Which plants? All plants that have root hairs. Root hairs are formed by intracellular bacteria, and these intracellular bacteria provide significant amounts of a plant's nutrient needs. This is in addition to the nutrients derived from the soil? Time for another book. I thought long and hard about whether another trip down the writer's rabbit hole would be worth it. When I emerged the first time, I had a manuscript for Teeming with Microbes, the Organic Gardener's Guide to the Soil Food Web, Timber Press, 2006. I made that journey because I was as excited then as I am now about bacterial endophytes and the rhizophagy cycle. I knew other gardeners would benefit from knowledge of the soil food web, a cycle which had been uncovered primarily by Elaine Ingham, but was not yet generally accepted. If there was an introductory book on the subject, other people might get excited about Dr. Ingham's work. And I would have gardeners to talk to about microbes, soil, and plants. Teeming with Microbes, you do need to read it, is all about the soil food web as we knew it at the time. At its core is this premise: plants are in control of soil microbes, which they attract to their root zones. These microbes produce nutrients in inorganic form so they can be taken up by the plant. The second time I went down the hole was to explain how plants used those nutrients. Teeming with Nutrients, Timber Press, 2013, explains how plants take in the nutrients the soil food web makes available to them and what happens to the nutrients once inside the plant. I never planned to go down the rabbit hole again.